Hi, my name is Casey Walters, and I'm in Ms. Benzi's quantitative literacy class, and we are working on Module 2, and I'm going to be going over our Excel report over probabilities. Number one, we were asked to, based on a survey of 500 men and 500 women, by Omnitel about their opinion on whether federal government bailout money should be used to help homeowners in default. The number giving each response is shown below. And what I did is I took all of the data that was given to us and I made a table here in Excel. And I have all the variables defined to the left over here. And I'm going to go ahead and press on some of these because I want to show that I do in fact have formulas in here so that I can get 100% scoring on this. Anyway, you'll see that in order to get the probabilities, I put in the formulas, and then over to the right in the first box it says reduced fractions, so that's probability in a fraction, and then the next is in a decimal to the thousandths and percent to the tenths. And then over here to further to the right, you will see the actual table with every single one of the responses, and I have them color coded so it's a lot easier to see. And so in summary, there was a survey conducted in 2008. They had 500 men and 500 women. They were asked to provide their opinions in a poll, and we found there were about 50% of the people who said no. Then we learned that if you chose a woman, the probability that she said no was 43%. And if you chose a man, the probability that he said yes or not sure was 43%. This is an example of empirical probabilities because they were actually calculated from a survey or an experiment. We can use empirical probability if data was collected from a good survey that was unbiased and random samples were taken. Then the probability found from this survey can be used to project outcomes for what you would think could happen on a larger population. Okay, and then moving on down to number 2, it's probabilities on rolling a die, and I've actually got the question down below here. I want to make sure that I say it correctly. But basically what it is in this problem we were asked to find the probability of rolling 2 die at one time and getting the list of results. And in doing so, I found that the probability of getting the sum of an even number would be 18 to 36, or 1 out of 2, or as a decimal, that'd be 0.5 or 50%. Next, I found the probability of rolling the product of a prime number would be 5 and 36, or 1 and 7, or as a decimal, it'd be 0.13, or rounded to 0.14, or 14%. The next part asks us what is the probability of the sum being a multiple of 3, and that would be 12 out of 36, or 1 in 3, or as a decimal, it'd be 0.333, or 33.33%. Finally, we were asked what the probability of getting a product of 12 would be, and that is 7 in 36, or 1 in 5, or as a decimal, it'd be 0.194, or 19%. And you will see that I have a table here that defines the variables, and then you will see that I also have the where I worked out the problems here, and then my tables over here are color coded, but they also have the functions and everything in the cells. So moving right along, we're on number 3, and it was about a lottery ticket. And in this problem, we were asked to create a table using the odds to calculate probabilities for each numerical outcome from the player's perspectives. And in doing so, I found that the expected outcome would be a loss of $1.93 for the buyers and a gain of $1.93 for the sellers. The seller's expected outcome for buyers for selling, sorry,